permanent deformation. Okay, if the load is applied outside its elastic limit, means beyond its elastic limit, there will be a permanent deformation will be there. Permanent deformation will be taking place, and that condition is dangerous. The structure will fail. Suppose if you are constructing a bridge, so in that bridge we are putting iron rod and other things also. So those iron rods, if it will be loaded beyond its elastic limit, then some bend and structural failure will take place. Structural failure will take place. What will happen? Suppose if I am able to lift the load of 5 kg, but I will start lifting 10 kg, 20 kg, then what will happen? My hand, some problem will occur on my body. It may be some permanent problem will occur on my body. Failure also will be taking place for my hand. So, if the load is applied within its elastic limit, you will be able to extend the life of the body. Correct? So, what actually it is, the meaning is, if the load is applied within the elastic limit of the body, then the body's life will be more. Whereas if beyond the elastic limit the body's life will collapse, failure of the material will be taking place. Okay, next one, if the load is applied beyond the elastic limit of the body, failure will be taking place. The body will fail. The body will fail. Okay. Now, so note it down. Right. Now, next topic we are going to study, that is stress strain curve. That is also a very important part. Stress strain curve. Right. So, stress and strain curve. So, two axis, we are taking it as x-axis and we are taking it as y-axis. On x-axis, let us take it as strain. On x-axis, y-axis, let us take it as stress. So here on y-axis, we are taking stress. On x-axis, we have taken as strain. Right, very good. Okay, right. I will tell you that what is the strain, also volumetric strain, shearing strain. Just like shearing stress was there, shearing strain is also there. Okay. Now, in this stress strain curve, what is the concept? First understand. So, suppose at this is the point 0. Now, any material is there, any body is there, and that particular body, you have started applying load from 0 onwards, right? So, okay, so what it is there, as we have told that within elastic limit, stress is directly proportional to strain. So, if you are increasing the load like this, So at one particular point, suppose this is the elastic limit. So this curve will be a straight line. Straight line. Why? Because stress is, so with the elastic limit, stress is directly proportional to strain. So if you are applying the load within its elastic limit, so whatever deformation will be taking place, that also will be proportional to the stress, and you will be reaching a particular point here. Okay, so suppose this is O and this particular point is A, right? So up till A, if it is loaded within elastic limit, if you are removing it back, it will come back to its original position. Right. Now, further, from A, if you have started loading, so strain will increase little bit. At some particular point B, right? So now some deformation, more deformation has taken place. There are chances that the body will come back to its original position, but not completely. Not completely. It will show the sign of deformation. Right? Like, if I have the capacity to lift 5 kg, but I have lifted 10 kg of load for some time. So, once I remove that 10 kg load from my body, from my hand, still I will be feeling some type of pain on my body. That shows that some strain is already available on my body. Okay, though some relief I may get from that more severe pain, it will be, that pain will get reduced, but still that pain, if it is there, it means some type of strain is already available on the body. So the same case will be there up till point A. Okay, so this point we can say elastic limit. Up till elastic limit, if the body is loaded, no problem. But when from A, if it is crossing the load, at that time deformation will increase. Right? Okay, and this point B is called yield point. Correct? So A point is elastic limit, B point is yield point. Yield point means what? The point at which the body may come back to its original position, but with some deformation. Completely deformation removed, that will be there only up to elastic limit. But up to yield point, it will not fail. It will come back to its original position, but not completely. Okay, so you can say that coming back to original position, but not completely. Some signs of deformation, the body will show. Understood, gentlemen? This is called yield point. Very important. Stress strain curve is very important. Okay. Now, further you have increased the load. So in that case, what it will be there? It will be strain will increase rapidly. With little increase in stress, strain will increase rapidly. Okay. At this some particular point, you can say this is some C point. The strain will increase. This point is called ultimate point. ultimate stress. Ultimate stress. Ultimate stress means its maximum value reached. Though strain has taken place, but it has not failed till now. Means breaking and other things has not taken place. Deformation has taken place very rapidly. Okay, so ultimate tensile strength or ultimate strength. This is called ultimate stress or ultimate strength. Better. Ultimate strength. So C, this point C is ultimate strength. From B to C, strain rises rapidly with small increase in stress. Stress you are not increasing more, very little. Then also strain is rising very rapidly. You are reaching up to the point of ultimate strength. Right? When you are increasing from C to some point D, failure, broken. Okay, so failure has taken place of the particular body. Right? So like some overbridge and other things are made. So when it is made new, problem is not there. Okay, within the elastic limit, the body is loaded very good. Correct, I agree. But what happens in due course of time, that particular load, you can say, is kept permanently for a longer time, though it is within elastic limit. Slowly as the time passes, okay, the body will start developing some type of strain. Slowly some type of strain will be developing. That's why the structure which is, you can say, some 20 years old or some 50 years old, 100 years old, okay, it is getting collapsed. Even the overbridges and all, it is getting damaged. So how it is damaged? Because though it is loaded up to the elastic limit, but then also that load is creating slowly little deformation, and it is reaching up to the stage of D after a longer time, and then failure takes place. That's why in between every building has to be checked. For each and every building, for each and every body, there is a life. There is a life. So engineers, they used to determine the life of the body, that though the body is loaded within elastic limit, it will be working perfectly, it will be giving its smooth functioning only up till these many years. After that, there is no surety of giving its smooth performance. It may fail for each and every body, including building, including overbridge, including road. For each and everything, life is there. Okay, and that life is given on the basis of its elastic limit. Means when permanent deformation, the moment this permanent deformation will start, it means it is going to get failed. 100%. We have to be cautious. Understood? So this particular stress. Now what you can say, suppose you have stretched any body up to the ultimate strength, or suppose at some particular point here, suppose it is D is there, at some particular point E. From yield point, when you have moved up to the point E, and you have left, body will not regain back its original position. You can say that the body will develop this. This is called permanent set. What it is called? Permanent set. Permanent set means what? Permanent deformation. Permanent deformation. Okay, it will not be coming back to its original position. After yield point, it will not be coming back to its original position. It will be permanently that the deformation will be there. Okay, so this particular part is called permanent set. Okay, so somewhere you take it as P. So OP is permanent set. Permanent set. What is this permanent set? The body is permanently strained. Permanently strained. Okay, permanent set. Set means it has set to its new position in strained condition. Once we have stressed, it will be in stressed condition only. Right? Okay. So the body is permanently strained. So this is stress strain curve. Right? Very important for the examination point of view. So from O to A within elastic limit, the body can return back to its original position. From A to B, some type of deformation sign will be there, but chances are there that it will be regaining back its original position, but that sign of some deformation will be existing from A to B, and B is called the yield point. B is called the yield point. So from this mechanical behavior or the stress strain curve, what actually we have understood? We have understood that if any body has to be applied with some load, that load should be well below its elastic limit so that its life can be increased. Correct or not? So that body, when you are going to design any particular type of body, being an engineer, so you have to find out that this particular body will be able to withstand how much load. And that particular body's loading capacity, we should apply the load. So when it should be less than its elastic limit, its life will be longer. Correct? So we should have each and every point with us, each and every value with us. For any type of body, we should know that what is A value, what is B value, what is C value, everything we should know. Okay, so in labs and all, when you are going for testing of the materials, when you are going for testing of the materials, each and every material is being tested, that okay, by applying the load in the laboratory itself, if load is applied, this much load is applied, then again removed, then checked for its dimension, whether it has changed or whether it has not changed, then again some more load is applied for some time, and again load is removed, and then again it is checked for its dimension, whether any change has occurred or not, and in this process the load is applied up to yield point, up to point C, up to point D. When failure has permanently taken place, then it will be written that for this particular material, this is the failure point, this is the ultimate strength, and this will be the point of B, yield point, and this is the elastic limit. So that's why in examination, for each and every body, this is already you wrote it down. Okay, so for each and every body, you will be given, even if material is there, you will be given modulus of elasticity. Okay, there is an important phenomenon, what it is called creep. Creep. So what actually creep is, even if the body, what I told, even if the body is loaded within its elastic limit, okay, so with the passage of time, the body will develop some type of permanent deformation. Body will be developing some type of deformation which will become permanent over long duration. That's why I told that even if structure, building, each and everything is having its own life. Right? So creep is what? This is a slow process. A slow process. Slow process means what? Immediately it will not occur. Over a passage of time, 10 years, 20 years after that, okay, so if you are purchasing a new vehicle, so that vehicle immediately it will not be showing any type of problem. But when it has become 10 years old, 20 years old, so some slowly different types of problems will start appearing. So why it is so? Because due to that creep. So a body is subjected to sometimes high temperature, sometimes low temperature. Correct or not? A body is subjected to sometimes high load, sometimes low load. A two-wheeler is designed for 2 persons only. But we will be going, some full family is going. So 2 children and husband and wife, everybody is the vehicle is loaded. Some type of creep will be there. Permanent deformation will be occurring. Correct or not? So that is there. So creep is a slow process. In that what happens over passage of time, you can say maybe in years, a long duration. Though the body is loaded within its elastic limit, the body will develop a permanent deformation which will lead it towards its failure. Towards its failure. 100% failure will be there. So failure. That is called creep. Very important property when the body is constantly loaded. Okay, constantly loaded. So this occurs generally. This creep occurs generally when fluctuating loads are applied and the body is exposed to different cycles of load, including temperature change, changes. Okay, gentlemen? Right. So please note it down.